Hi, my name is Ms. De Leon, and today we're going to talk about relations, functions, domain, and range. Our objective and language objective for today. After today, I will be able to compare and contrast functions and non-functions, as well as represent relations in 4 different ways. A relation is a set of input and output values, and they're usually represented in ordered pairs. And you should have already seen this before. An ordered pair is basically an x, comma, a y value. The x represents the input value, the y represents the output value. A relation can be expressed in 4 different ways. One is with the graph, another is with ordered pairs, a table, or a mapping. You can find this in your notes. This should be on the paper that you picked up as you walked into the class. And as I make annotations on this slide, I want you to also make sure that you copy those annotations onto your notes. So suppose I have this graph and I want to represent this relation in terms of ordered pairs. Remember, an ordered pair is an x value, comma, a y value. So we want to put each one of these points in terms of ordered pairs. Our first point is 0, 0, since it's at the origin. Our second point is 2 on the x-axis, 2 to the right on the x-axis, and 2 up on the y-axis. So that ordered pair would be 2, 2. Our third point would be 1, 2, 3, 4 on the x-axis, and 1, 2, 3, 4, 5, 6 up on the y-axis. So that ordered pair would be 4, 6. And we would do this for every point on the graph, and eventually we would end up with a list that looks like this. Now suppose that I want to represent this relation in terms of a table. Then all I have to do is I would have to take all of these x values, write them down on the x column, and all of my y values and write them down on my y column, which would look something like this. Notice they're in the exact same order. The only thing that they're missing are the parentheses and the comma. So it's pretty easy to write ordered pairs on a table. If I want to represent this relation in terms of a mapping, I would do the same thing again. I would write all of my x values on the x oval and all of my y values on the second oval. That would look something like this. Now here I chose to keep the same order, but I could have easily, I didn't have to follow any order in copying down the x and the y values, simply because all I have to do now to show that the 0 and the 0 correspond together is draw an arrow from my 0 to my 0. Since the 2 corresponds with the 2, all I have to do is draw an arrow from the 2 to the 2, and so forth and so forth. I could have written down this 2 below and left this 2 up here, and in that case I would have an arrow going from the bottom to the top, and that's fine as well. Not all mappings look like this. Now I want to talk about domain and range. My domain is basically all of my x values, and all I have to do is basically just write down every x value that I used in this relation. It's very easy since basically all I can do is just copy down the x column on this table, and I'm done. The range are all the y values. So all I have to do is again copy down all of the y values that I used. This is really easy since I have my ordered pairs, my mapping, and my table, which lists out my y values. So I'm going to copy down all those y values, and I'm done. And now I have to determine whether or not this relation is a function. Well, to be a function, you have to meet 2 different criteria. There's 2 different tests. And this part is not in your notes, so what I want you to do is I want you to pause this video and I want you to copy down both of these criteria down at the bottom of your notes. Okay, so to be a function, number one, the x values cannot repeat. That means that they cannot be used more than once. And number two, the graph must pass the vertical line test. The vertical line test is probably everybody's favorite test because it's really easy to do, but we're gonna test out both of these criteria. Okay, so the first one was that the x values cannot repeat. Let's look at our ordered pairs. Do we see any x value being used more than once? No. 0, 2, 4, 5, -5, -3, -2. I do not see the same x value used more than once. You can check with the table, you can check with the mapping. So in that sense, this is a function, but let's continue on to the second criteria. The second one is that the graph must pass the vertical line test. And if we look at our graph, to do the test, all you have to do is take a pencil, put it vertically, and then slide it from the left to the right. To pass the test, as you slide that pencil, the pencil should not touch should not touch 2 points or more at the same time. And you can see that as you're sliding your pencil, the pencil touches each point one time. Every time it slides through it, it touches 1 point at a time. It doesn't touch more than 1 point. And basically that's all we need because it passed the vertical line test. Again, we can say that this is a function. So what I want you to do is I want you to pause this video, and if you haven't already, finish copying everything on this slide.